In this video on systems of equations, we're going to be looking at the unique solution system. This is where we have three planes that all intersect at the same point. And that means that the single point is the only one that lies on all three planes, and it's also the only one in all of the points in three-dimensional space that solve our problem. We're going to look at a contextual problem first to get started. Here we have pet food. We're trying to feed our pet with different food packs, A, B, and C, and each of these food packs are made up of a different combination of protein, carbohydrates, and fats. All of them also come at a different cost. Our goal is to figure out the cost per gram for protein, carbohydrates, and fats based on the information above. Now, I don't know the cost per gram. They're unknown to me. So I represent unknowns with the variables x, y, and z. And the information in the bullet points at the top, each of those bullet points are equations. I can represent them with equations using these unknowns. And when I graph equations in three-dimensional space, they are planes. We'll see how each of these three planes interact. If they all meet at a single point, then I can solve the problem. So you'll notice that these bullet points here are conveniently written where I can actually easily transfer them to equations. So the first one, food pack A, I'll write an equation for that. So we'll start with an equal sign. On the right-hand side, I'm going to put in the cost of that pack, which we can see is $7. We don't need to worry about any dollar signs or grams or anything like that, just the numbers is fine. On the left-hand side, I'm going to put in the components of that cost. That's made up of the total cost for protein, total cost for carbs, and total cost for fats. So the total cost for protein is the number of grams of protein times the cost per gram. So that's 1 times x, or just x for short. Add that to the total cost for carbs, which will be 1 times y, or y, plus z. My second equation from the second food pack will be the total cost for protein. Now that is 2 grams times the cost per gram. That's 2x. You're probably getting the hang of it by now, plus 3y, plus 4z, and this one cost me $23. Lastly, 3 grams of protein, 5 grams of carbs, and 1 gram of fat equals $18. So I have my three equations now, so I can put them into our system solver, which you can find on the website. And hopefully this will give me a value for x, y, and z. Over here, we can put the coefficients, that's the numbers in front of the variables or unknowns. I can put them in this array and it will solve it for me. Notice that with some of these terms, it doesn't look like I have a coefficient. For example, in the top row, x plus y plus z, it's actually 1x plus 1y plus 1z. And this one down here is also 1z. We just don't write the 1. However, it is there, so we can put those into our array. So the first row would be 1, 1, 1, 7, and the second row would be 2, 3, 4, and 23. And you follow that same pattern for the third row. Once you've done that, we press solve in the top right-hand corner, and we get x equals 1.5, y equals 2, and z equals 3.5. Now it's important that we write this in context. So these are all dollar figures, so we should put dollars on them and write them to 2 decimal places. Let's look at this graphically. So here in the GeoGebra app, we've graphed all three equations as planes in three-dimensional space, and as we can see, that point there in blue is the only point where all three meet, which is the coordinate or prices that we found before. So to sum up everything in this video, we can see that we have a unique solution when all three planes intersect at a single point in three-dimensional space. Now, the way to spot that is if we see that the coefficients have no pattern or no relation at all between them, and the same thing with the constants on the right-hand side. Here's our solution as we found before using our system solver. So what's happening here is that we have three planes all facing completely different directions, so they're able to meet at a single point. And this is the only point that solves all three equations at the same time, because it's the only one that's lying on all three planes. And that's it. Thanks for watching.